Hey guys, Miss Subin here, and today we're going to be looking into powers and exponents, and we're going to look into the power of 0. So again, our objectives today, we will review vocabulary when dealing with powers and exponents. We will rewrite exponential expressions in expanded form and standard form, and today we will discover the rule for the power of 0. So for our vocabulary, we have a couple different things that we need to review. So the first thing is 5 to the third power. That's how you can read that, or 5 cubed. I'm just going to fill in some vocabulary here. This 5, our large number, is our base. I am going to be referring to it that way, so you do need to know that word. And then our small number, the power that we're using, is known as our exponent. Five to the third power can be written in expanded form by doing 5 times 5 times 5. We write the base only, and then the exponent tells us how many times we're going to write it. So 5 times itself 3 times, for a total of 3 times. And then for standard form, we can use our calculator here. I just want to know what the actual value of 5 times 5 times 5 is. Well, 5 times 5 is 25, and then 25 times 5 is 125. You can also find this in your calculator by doing 5 times 5 times 5. So for standard form, it's just the value, which 5 to the third is 125. You're going to practice this some more in another activity, but for the purpose of the video, we're going to move on for our power of 0. Now for the power of 0, this should be something that's kind of new for you. We're going to figure out what happens when you take any number and raise it to the power of 0. So for this one, we're looking at 2 to the power of 0. We're trying to figure out what will the final answer look like. So we're going to do an investigation together where we're going to start with a higher exponent and work our way down to 0 and see what happens. So 2 to the third is 2 times 2 times 2, which if I put it in the calculator is 8. Be careful, it's not 6. 2 times 2 is 4. 4 times 2 is 8. 2 to the power of 2, that's going to be 2 times 2, which is 4. 2 to the power of 1, that's just going to be 2 for both the expanded and the standard form. Now we want to be careful. We're looking for a pattern here, and I'm going to tell you right now, it's not going to be 0 in that last box. We need to look at 8, 4, and 2 and see if we can figure out the pattern. So let's look a little bit more closely. So this is the same table that we just filled out. It's just typed so it's easier to read. We're going to find a pattern and we're going to see if we can find the rule for 0. So let's look at the values here. We're starting at 8 and we're going to 4. We can do that by subtracting 4, but 4 minus 4 is not 2, so that's not the right pattern. 8 divided by 2, that'll give me 4, and 4 divided by 2, that'll give me 2. So that's a pattern that we can work with. So again, 8 divided by 2 gives me 4, and 4 divided by 2 gives me 2. So here's a pattern that works the whole way down our table. If we continue to follow this pattern and divide by 2 again, I'll get 1 for our solution for the next power as we go down. This is kind of confusing because if we're not writing 2 at all, wouldn't it be 0? And the answer is no. What's happening here is that when we take a power of any number to the power of 0, what we're doing really is we're taking that number and we're dividing it by itself. It's kind of confusing, but we're getting rid of that last 2 using division instead of subtraction. Let's keep giving this a try. I'd like for you to do this on your own paper so you can work ahead of me. If you want, you can pause me here so that you can stay ahead of me and then listen to my answers, but I'm going to do the same thing with 3 and 4. So 3, I want to do 3 times 3 times 3, which 3 times 3 is 9. 9 times 3 is 27. 3 squared, or 3 to the power of 2, is 3 times 3, which is 9. And then 3 to the power of 1, we're just going to write 3 once. So our solution is 3. Looking at our pattern, 27 divided by 3 gives me 9. Sorry, my pen wrote that really weird. So again, 27 divided by 3 gives me 9. If I follow this pattern, it works again, dividing by 3. Since our pattern works multiple times, we can extend it to see what happens when we decrease our power again to 0. 3 divided by 3 gives me 1. So again, 3 to the power of 0 is actually going to be 1, because taking a power of 0 is the same as taking a number and dividing it by itself. We're dividing it away. We're not subtracting, so you should not get 0. Right? So same thing again. This time I have 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. 4 squared is 4 times 4. 4 to the first is just going to be 4. If we look at our pattern, 64, 16, and 4, we can get down our table by dividing by 4. So that means I want to go from 4 to my next box by dividing by 4. So 4, this must be 4 to the 0 power. 4 to the 0 power is the same as 4 divided by 4, which is 1. Again, it's not going to be 0. It's not that it doesn't exist. It's that it gets divided away. And when we divide, our answer is going to be 1. We can't divide and get 0. So here's the rule, and I'd like for you to write this down somewhere. If you need more time, you can always pause me here. For our power of 0, our rule is anything to the power of 0 is 1. Remember that the power of 0 is the same as taking a number and dividing it by itself. Now, we don't really have to show any work for these problems, but I'm going to show you dividing a number by itself always equals 1. But once you know this rule, you can just use this rule. Anytime you see any number to the power of 0, your answer is going to be 1. So let's look at some examples of this. 12 to the power of 0. Well, power of 0 means take the base and divide it away. 12 divided by 12 is 1. That's my final answer. We can do that with really large numbers as well, like 42. 42 to the power of 0, we take 42 and we divide it away. When we're dividing, we'll get an answer of 1. $1.56, really ugly. You would think we need a calculator to solve 1.56 to the 0 power. But what I'm going to do is I'm going to take that 1.56 and I'm going to divide it away. It's not that it didn't exist. It's not that there's no answer or that it's 0. We're taking that value and we're dividing it away. 1.56 divided by itself will be 1. And you can even check that in a calculator. 1.56 divided by 1.56 gives me 1. This one is a little bit more complicated because it's a fraction, but 1/4 divided by 1/4. Let's see what happens. Now I'm going to throw a concept at you that you probably haven't done in a while. We're dividing fractions, so I need to do keep, change, flip. I'm going to keep the first one the same and change to a multiplication problem. and multiply by the reciprocal. Here I get 1 times 4 for the numerator, and 4 times 1 in the denominator. 4 divided by 4, that's still 1. Now the good news, that last one's kind of crazy. You don't have to show me any of that work. I'm showing you that it works, but if you know this rule, if you see the power of 0, the answer will always, always, always be 1. You're going to have a chance to practice this today, but at this point, I'd like for you to go ahead and get started.